Download this code from codegive.com, link in the description below. Asynchronous PHP requests and reactive responses with php-fpm, a deep dive. This tutorial will guide you through the process of creating asynchronous PHP requests and handling reactive responses using php-fpm. We'll explore different techniques, including event loops, message queues, and real-time communication, along with practical code examples. We'll focus on practical and manageable approaches that are best suited for the common use cases you might encounter when integrating with FPM. Why asynchronous operations? PHP, by default, operates synchronously. This means that when a script makes a request, example to an external API, database, or another part of your application, it waits for the response before continuing. This can lead to significant performance bottlenecks, especially when dealing with slow or unreliable resources. Asynchronous operations allow your PHP script to initiate a request and continue processing other tasks without waiting for the response. When the response finally arrives, a callback or event handler is triggered to process the data. This leads to increased responsiveness, improved resource utilization, and better overall application performance. Limitations of php-fpm and true asynchronicity. It's essential to understand that php-fpm, being a process manager, doesn't directly support true asynchronicity in the same way as languages like Node.js or Go. php-fpm manages a pool of processes, and each process handles a single request at a time. However, we can achieve concurrency and pseudo-asynchronicity by leveraging external tools and techniques. Think of it more as non-blocking operations, where the php-fpm worker process doesn't have to actively wait for a long-running operation to complete. Techniques for asynchronous operations with php-fpm. Here are the primary approaches we'll cover. 1. Message queues, recommended for robustness and scalability. Using message queues like RabbitMQ or Redis pub/sub is the most reliable and scalable approach for handling asynchronous tasks. A php-fpm worker publishes a message to the queue, and another worker, or set of workers, subscribes to that queue and processes the message. 2. PCNTL_fork, advanced. Use with caution. This approach involves creating child processes that run in parallel. While it offers the potential for true parallelism, it's generally not recommended in typical web applications with php-fpm due to its complexity, resource limitations, and potential for race conditions. It's best for long-running background tasks handled by a dedicated CLI script. 3. Curl_multi_functions. For concurrent HTTP requests, the set of functions allows you to initiate multiple HTTP requests concurrently within a single PHP process. It's suitable for scenarios where you need to fetch data from several external APIs without blocking the main request thread completely. 4. Event loops. Using libraries like React PHP or EMP, these libraries provide a framework for building event-driven, non-blocking applications in PHP. They are powerful but require a significant shift in how you structure your code and are generally better suited for long-running processes, not typical HTTP requests. 1. Message queues, RabbitMQ, Redis pub/sub. This is the recommended approach for most asynchronous task scenarios, especially in production environments. Architecture **** producer **** the PHP-fpm worker that receives the initial HTTP request and initiates the asynchronous operation, example sending an email, processing an image, updating a database. The producer sends a message to the queue. ***message queue ***, a broker like RabbitMQ or Redis pub/sub that stores and manages messages. ***consumer ***, one or more PHP CLI scripts, or php-fpm workers dedicated to consumption, that subscribe to the queue and process the messages. Example, using RabbitMQ. Prerequisites asterisk. Asterisk a running RabbitMQ server, install via Docker, package manager, or cloud provider. Asterisk the php-amplib/php-amplib library installed, composer require php-amplib/php-amplib. 1. Producer, API endpoint in your php-fpm application, API/process_data.php. Explanation asterisk. Asterisk connects to RabbitMQ asterisk establishes a connection to the RabbitMQ server using the provided credentials. Asterisk declares a queue asterisk declares a queue named data_processing_queue. The durable flag, set to true, ensures that the queue survives server restarts. Asterisk creates a message asterisk encodes the data, and timestamp, into a JSON message. The delivery mode is set to AMQP message delivery mode persistent to make the messages persistent, meaning they won't be lost if the RabbitMQ server restarts. Asterisk publishes the message asterisk sends the message to the queue. Asterisk closes connection asterisk closes the channel and connection to free up resources. Asterisk error handling asterisk includes a try-catch block to handle potential exceptions during the process. 2. Consumer, CLI script, consumer.php. Explanation asterisk. Asterisk connects to RabbitMQ asterisk similar to the producer, it establishes a connection. Asterisk declares the queue asterisk ensures the queue exists. Asterisk basic_QoS asterisk this is crucial for controlling the number of messages the consumer receives at once. Setting prefetch_count to 1 means the consumer will only receive one message at a time and won't fetch another until it acknowledges the first. This prevents the consumer from becoming overwhelmed. Asterisk basic_consume asterisk sets up a consumer to listen for messages on the queue. Asterisk the $callback function is executed whenever a message arrives. Asterisk important asterisk the $message delivery _info channel basic_ac $message delivery _info delivery _tag line acknowledges the message. If the consumer crashes before acknowledging, RabbitMQ will requeue the message to be processed again by another consumer. Always acknowledge messages to prevent data loss. Asterisk while $channel is _open, $channel wait, asterisk this loop keeps the consumer running indefinitely, waiting for messages. Asterisk sleep, 5, asterisk simulates a long-running task. Replace this with your actual data processing logic. How to run the example asterisk. 1. Start the consumer asterisk in a terminal, run, php-consumer.php. 2. Send data, producer use curl or a similar tool to send a post request to your php-fpm endpoint. Replace http://yourdomain.com/api/process_data.php with the actual URL of your API endpoint. 3. Observe asterisk you'll see the consumer script output the received message and then simulate processing it. Your API endpoint will immediately return a success response without waiting for the processing to finish. Key considerations for message queues asterisk. Asterisk message serialization asterisk use a consistent serialization format, JSON is common, for your messages. Asterisk error handling asterisk implement robust error handling in your consumer to deal with unexpected errors during processing. Log errors and potentially requeue messages, with a retry limit, for failed processing. Asterisk idempotency asterisk ideally, make your consumer idempotent. This means that if a message is processed multiple times, example due to a requeue, the result is the same as if it were processed only once. This prevents unintended side effects. Queue naming. Use descriptive queue names. Message acknowledgement. Always acknowledge messages after successful processing. Consumer scaling. You can run multiple instances of the consumer script to increase processing capacity. Monitoring. Monitor the health and performance of your message queue and consumers. Advantages of message queues. Decoupling. Completely decouples the producer and consumer, making your application more resilient. Scalability. Easily scale the number of consumers to handle increasing workloads. Reliability. Message queues provide guaranteed delivery, with proper configuration. Resilience. If a consumer fails, messages will be requeued. Disadvantages. Complexity. Requires setting up and managing a message queue server. Overhead. Adds some overhead due to message serialization, queuing, and delivery. Eventual consistency. Introduces eventual consistency, as the data processing happens asynchronously. Example, using Redis pub/sub. Redis pub/sub is a lighter weight alternative to RabbitMQ, suitable for scenarios where you need simple message broadcasting. Prerequisites. A running Redis server. The Predis library installed. Composer require Predis. 1. Producer, API endpoint, API/process_data.php. 2. Consumer, CLI script, consumer.php. How to run the Redis pub/sub example. 1. Start the consumer in a terminal, run, php consumer.php. 2. Send data, producer use curl or a similar tool to send a post request to your php-fpm endpoint. Important considerations for Redis pub/sub. No message persistence. Redis pub/sub does not guarantee message delivery. If the consumer is not running when a message is published, the message is lost. This is a key difference compared to RabbitMQ. Simple broadcasting. Redis pub/sub is best suited for broadcasting messages to multiple subscribers. Limited features. It lacks features like message queues, acknowledgements, and routing capabilities found in more robust message queue systems. 2. PCNTL_fork, advanced, use with extreme caution. PCNTL_fork creates a child process that runs concurrently with the parent process. The child process receives a copy of the parent process's memory space. Why it's generally not recommended for web applications. Complexity. Requires careful management of child processes, signals, and shared resources. Resource intensive. Creating new processes consumes significant resources, especially memory. php-fpm interactions. Integrating PCNTL_fork with php-fpm can be tricky. php-fpm is designed to manage worker processes, and PCNTL_fork adds another layer of process management. It's not recommended to fork within the context of a single request handled by an FPM worker, as it can interfere with FPM's process lifecycle. Race conditions. Difficult to prevent race conditions when accessing shared resources. Example, demonstrates the concept, but not recommended for typical web apps. Important asterisk. The child process must call exit, after completing its task. Otherwise, it will continue executing the parent process's code, which can lead to unexpected behavior. Asterisk use pcntl_wait, in the parent process to wait for the child process to finish, optional. Asterisk this example is highly simplified and does not handle error conditions or signal handling properly. In a real application, you would need to implement robust error handling. When pcntl_fork might be appropriate, for dedicated CLI scripts, not web requests. Asterisk long-running, CPU-intensive tasks. Asterisk if you have tasks that are computationally expensive and can benefit from true parallelism, and you can manage the complexity and resource usage, pcntl_fork might be considered. But even then, using a message queue and distributing tasks across multiple consumer processes is usually a better option. Asterisk dedicated CLI scripts. Asterisk pcntl_fork is more suitable for CLI scripts that run outside the context of a web request. 3. curl_multi_functions, concurrent HTTP requests. The curl_multi_ functions allow you to perform multiple HTTP requests concurrently within a single PHP process. This can be useful for fetching data from multiple external APIs without blocking the main request thread completely. This is not true asynchronicity, but it does allow you to start multiple operations at once and then collect the results as they become available. Example asterisk. Explanation asterisk. 1. Initialize multi-handle asterisk curl_multi_init, creates a multi-curl handle. 2. Create individual handles asterisk for each URL, a separate curl handle is created using curl_init. The curl_opt_return transfer option is set to true to ensure that the response is returned as a string. 3. Add handles to multi-handle asterisk each individual curl handle is added to the multi-curl handle using curl_multi_add_handle. 4. Execute handles asterisk the curl_multi_exec function executes the handles concurrently. Curl_multi_select waits for activity on any of the curl handles before continuing. 5. Get results asterisk after the handles have finished executing, curl_multi_get content, retrieves the content from each handle. 6. Clean up asterisk the handles are removed from the multi-curl handle using curl_multi_remove_handle, and closed using curl_close. 7. Close multi-handle asterisk the multi-curl handle is closed using curl_multi_close. Advantages of curl_multi_***. Asterisk concurrency asterisk allows you to perform multiple HTTP requests concurrently, reducing the overall execution time. Asterisk relatively simple asterisk easier to implement than pcntl_fork. Disadvantages asterisk. Asterisk not true asynchronicity asterisk the PHP process still waits for all requests to complete. It's more of a non-blocking concurrency approach. Asterisk limited error handling asterisk error handling can be complex, especially when dealing with multiple requests. Asterisk can still block asterisk if one of the requests is very slow or hangs, it can still delay the overall process. 4. Event loops, React PHP, AMP, more advanced. Event loops provide a framework for building truly non-blocking, event-driven applications in PHP. They require a different programming paradigm and are typically used for long-running processes rather than individual HTTP requests within php-fpm. These are best suited for creating specialized services. React PHP asterisk. React PHP is a popular event loop implementation for PHP. It allows you to write non-blocking code using callbacks and promises. AMP asterisk. AMP is another event loop library that offers a similar approach to React PHP. Why they are less suitable for typical php-fpm web applications asterisk. Asterisk complexity asterisk requires a significant change in coding style. Asterisk long-running processes asterisk event loops are designed for long-running processes, not the short-lived requests handled by php-fpm. Asterisk php-fpm integration asterisk integrating event loops with php-fpm can be complex and may not provide significant benefits in most cases. Conclusion asterisk. Choosing the right approach for asynchronous operations in PHP with php-fpm depends on your specific needs and the complexity of your application. Asterisk for robustness and scalability asterisk message queues, RabbitMQ, Redis pub/sub, are generally the best choice for most scenarios. They provide decoupling, reliability, and scalability. Asterisk for concurrent HTTP requests asterisk curl_multi_ asterisk functions are suitable for fetching data from multiple external APIs concurrently. Asterisk PCNTL_fork, advanced, use with caution reserved for specific scenarios where true parallelism is required, and you can manage the complexity and resource usage. Primarily useful for CLI scripts outside the context of web requests. Asterisk event loops, React PHP, AMP, more advanced best suited for long-running, event-driven processes outside of the typical PHP-fpm request/response cycle. By understanding these techniques and their limitations, you can create more responsive, efficient, and scalable PHP applications. Remember to prioritize code clarity, error handling, and resource management when implementing asynchronous operations. Good luck.